Good morning. Today we're going to talk some more about dilations and sequences with dilations. So we've already learned about the different types of rigid transformations. So those are your translations, your reflections, and your rotations. We've also talked some more about dilations, and now we're going to put those all together to do a sequence including dilations. And we're going to do that through an escape room. So as we can see, we want to solve each puzzle in order to get out of the cursed classroom and haunted school. We'll go ahead and click on here to start. So first we're going to go over our learning targets. So our learning targets are we are going to develop strategies for performing sequences of transformations that involve dilations. So we're going to find ways to solve a problem that involves multiple transformations and including dilations. And we are also going to recognize that for a sequence of transformations that may involve dilations that the image is similar to the original figure. Remember, similar means that they have congruent angles, but that their side lengths may be smaller or larger depending on the scale factor. So first we're going to try to develop some of that prior knowledge of what we've talked about the past couple days. So remember that we are trying to find the scale factor between rectangle ABCD here and A prime, B prime, C prime, D prime here. And our first question is, how do we find a scale factor? So we find a scale factor by dividing your new image by your original, by its corresponding parts. So for our new image here, we have a height of 6, and our original image has a height of 3. So we need to do 6 divided by 3, and that gives you what? So that gives you 2, so our scale factor would be 2. Correct. Next, we're going to kind of connect our dilations to the real world. So the question is, which of these is not an example of a dilation? So is shrinking a photo an example of a dilation? Yes, it is, because remember that's just making the photo get smaller, so it's changing its size, so that is a dilation. Is different size coffee cups a dilation? Yes, that is a dilation, because again, you're getting them either smaller or larger. Is playing with a Rubik's Cube a dilation? No, that is not a dilation, because that would be rotating, because you're rotating the Rubik's Cube in order to solve it. So that would be playing with the Rubik's Cube is not a dilation. And just to double check, pupil in your eye expanding. So remember we discussed that if someone has a concussion, that means that the pupil in your eye would expand, which means it's growing in its size. So that is a dilation. So our answer must be playing with the Rubik's Cube. So now we are going to go ahead and start our notes by entering our first room of our escape room. We have 40 minutes to escape before Bob the school ghost finds us. So we're going to click here to solve the first puzzle. So here we have puzzle 1. It says that Abram is learning to program graphics on a computer, and he draws this triangle here of ABC and reflects it across the x-axis to form triangle A prime, B prime, C prime. So the first question is, what are the coordinates of this A prime, B prime, C prime? How do we reflect it over the x-axis? So we can see here that A is at 2, -2. So when we reflect over the x-axis, that means our x values will stay the same and our y values will flip. So we're at 2, -2, which means that this will go from 2, -2 to 2, +2. Same for B. We're at 6, -2. So then we go to 6, +2, and the same for C, which means that is our answer M of A prime at 2, 2, B prime at 6, 2, C prime at 4, 6, or N, where A prime is at -2, -2, B prime is at -6, -2, and C prime is at -4, -6. Yes, so our first answer is going to be that M. So that A prime at 2, 2, B prime at 6, 2, and C prime at 4, 6. So we have found a candle, and so far we have our letter M. So you might want to write that down because that will help you with the riddle later. Next we have puzzle 2 here. So we see that our new triangle at A prime, B prime, C prime is using a scale factor of 1/2 with the center of dilation at the origin. So we need to find the coordinates of our next triangle of A double prime, B double prime, and C double prime. So again, when we're given a scale factor, how do we find the new coordinates? Yes, so you multiply your original coordinates, so of our A prime, B prime, C prime, by your scale factor. So our A prime here is at 2, 2. So we're going to take each of those points and multiply them by our scale factor. So that 2 times 1/2 is equal to 1. And again, 2 times 1/2 is equal to 1. So that means our A prime will now be at 1, 1. We will do the same for B prime. So our B prime is at 6, 2. So when we have 6 multiplied by our scale factor of 1/2 is equal to 3. And 2 multiplied by our scale factor of 1/2 is equal to 1. Go ahead and do that same work to solve for problem C prime, which is located at 4, 6. Yes, so we can see that our C prime double prime will be located at 2, 3, which means that our second answer must be A, where A double prime is at 1, 1, B double prime is at 3, 1, and C double prime is at 2, 3. For puzzle 3 here, we need to describe the coordinates of the vertices that change from triangle ABC to the reflected figure of A prime, B prime, C prime. So again, this is that triangle that we were just working with, and we need to see what has changed between the two. So we can see, and again, this is on page 101 now, that our original vertices were at 2, -2, 6, -2, and 4, -2. So we need to see what happens to the x values after a reflection. So remember, your x values are your first digits. So we can see we went from 2, -2 to 2, +2. We went from 6, -2 to 6, +2. 4, -6 to 4, +6. But again, we're checking with those x values. So what happened to our x values? Did they become their opposites, or did they stay the same? So we can see that our x values stayed the same. So that means our answer is T. Our x values stayed the same. Next, we go to puzzle 4. So this is still part of question 1 on page 101. And we need to describe what happened to our y values after we reflected. So again, we see that our originals went from 2, -2 to 2, +2, from 6, -2 to 6, +2, from 4, -6 to 4, +6. Remember, your y values are the second part of your ordered pair. So did our y values become their opposites, or did they stay the same? So we can see that our y values became their opposites, so our answer is going to be H. Next, we're at puzzle 5, which is part of question 1B. So we need to describe how the coordinates of the vertices changed from triangle A prime, B prime, C prime here to figure A double prime, B double prime, C double prime here. So what happened to our x and y values? So we can see we went from 2, 2 to 1, 1, from 6, 2 to 3, 1, from 4, 6 to 2, 3. So what happened to our x values and our y values? Did they double in size, or did they become half their size? So we can see they become half their size because half of 2 is 1, half of 6 is 3, half of 4 is 2. So they became half their size. So our answer would be I. Next, we have puzzle 6, which is going to be part of question 2A. So we have triangle ABC, and we're asking, is it similar to triangle A prime, B prime, C prime? So we have our triangle here, ABC, and we're asking, is it similar to triangle A prime, B prime, C prime here? So do we think yes or no? So we can see that our two figures are similar because they have the same angle measures and they have corresponding side lengths by a scale factor of 1. So our answer is S. Next, for puzzle 7, we have is triangle A prime, B prime, C prime, similar to triangle A double prime, B double prime, C double prime. So are they similar? We can see our answer is also going to be yes for that, because remember they have the same angle measures, so they are the same shape, they are just different sizes. So that means they are similar. For puzzle 8, we're asking, is triangle ABC similar to triangle A prime, B prime, C prime? So that's this triangle ABC. Is that similar to A double prime, B double prime, C double prime? Yes or no? Again, we see our answer is yes for this one because they are the same shape, they are just different sizes. For puzzle 9 here, we see that Grace wants to rotate rectangle PQRS 90 degrees clockwise. And again, we are on question 4 of page 102. She again wants to rotate it 90 degrees clockwise around the origin to form figure P prime, Q prime, R prime, S prime. We need to find out what are the coordinates of our figure P prime, Q prime, R prime, S prime. So again, remember when you rotate it 90 degrees clockwise, it's going to move one quadrant to the right. So we know that it will be in this quadrant here. And again, when you rotate 90 degrees clockwise, that means that you are changing the order of your coordinates, and you are making what was your x coordinate, now it's opposite. So for example, we will take our P here, which is at -5, 3. We are flipping the order. So now our 3 comes first and then our -5, and we would make what was negative positive. So we are now at 3, +5. Then we do the same for Q. So our Q is at -2, 3. So again, you want to flip that order. So now you have 3, -2. And what was -2 is now positive. So now you're at 3, +2. Now you're going to do the same for R. So R was at -2, +1. Again, you flip the order. So now you have 1. And then what was negative is now positive, 2. Then go ahead and do that for S. So S was at -5, 1. After a 90-degree rotation clockwise, where will it be moved to? So we see our S prime will now be located at +1, +5, which means our answer is going to be this W here. So here we can see our new triangle. So now it says Grace wants to dilate the image using a scale factor of 2 to form figure P double prime, Q double prime, R double prime, S double prime. So she wants to take this figure and dilate it by a scale factor of 2. So we need to see that this is the figure that Grace made. What mistake did she make? Did she make it larger than when it should have been smaller? Did she dilate the wrong figure? Or did she use the wrong scale factor? So we can see that Grace actually dilated her original image by a scale factor of 2 when she should have been dilating our new image, our P prime, Q prime, R prime, S prime. So remember, we are doing a sequence of transformations. So she's dilating this figure, not our original figure, which means our answer is actually E, that she dilated the wrong figure. Next, we have puzzle 11, which says, what are the correct vertices of figure P prime, or P double prime, Q double prime, R double prime, and S double prime? Remember, that means we are dilating our figure P prime, Q prime, R prime, S prime by a scale factor of 2. And again, what do we have to do when we dilate by a scale factor? Yes, so we multiply. So we're going to take P prime, which is at 3, 5, and take each of those points and multiply them by 2. So 3 times 2 is 6, and 5 times 2 is 10. So our P double prime will be located at 6, 10. Let's do the same thing for Q. So Q is at 3, 2. So So remember, 3 times our scale factor of 2 is 6, and 2 times our scale factor of 2 is 4, so that means our Q double prime will be at 6, 4. Our R prime was at 1, 2, so again, you take each of those parts of your ordered pair and multiply them by your scale factor of 2. So 1 times 2 is 2, and 2 times 2 is 4. Go ahead and do that for your S prime, which is located at 1, 5. So again, what is your scale factor, or what is your new coordinate of S double prime after using a scale factor of 2? So we see that our scale factor is going to be that S double prime is located at 2, 10. And again, we know this because if our original S prime was at 1 and we multiply that by 2, we get 2. Our original Y for our S prime was at 5 and we multiply that by 2, we get 10. So that means our answer must be R here. As we continue to the escape room, we can see that we are now on puzzle number 12, which goes with question 5 in your notes. So we can see 2 transformations are performed on triangle X. First, our triangle X is rotated 90 degrees counterclockwise to form triangle X prime. Then triangle X prime is dilated using a scale factor of 3/4 to form triangle X double prime. So we need to figure out which of these are true. Is triangle X similar to triangle X double prime? Is triangle X congruent to triangle X double prime? Is triangle X similar and congruent to triangle X double prime, or triangle X not similar or congruent to triangle X double prime? So we can see that our answer is going to be F here, that our triangle X is similar to triangle X double prime. And the reason we know this is because it was dilated, which means that they are similar but not congruent. So our triangle X double prime is actually a smaller version of triangle X. So it's not congruent, but it is similar. So again, that means that triangle X is similar to triangle X double prime. Next, we go to puzzle 13, which goes along with question 6 in our notes. So we see that Dario dilates triangle JKL in the coordinate plane using a scale factor of 1/2 to form triangle J prime, K prime, L prime. So we need to find out what are the coordinates of our new triangle J prime, K prime, L prime. So we are going to start by taking each of our points and multiplying them by our scale factor of 1/2. So we can see J is located at -6, 4. So we're going to take each of those 2 points and multiply them by our scale factor of 1/2. So what would be our new coordinates of J prime? So we can see our new coordinate of triangle J prime is going to be -3, 2. And we know this because -6 multiplied by 1/2 is equal to -3. And then 4 times 1/2 is equal to 2. So we have -3, 2. So we can see that our answer is going to be U. For our last puzzle, we can see that Dario wants to translate our new figure of J prime, K prime, L prime 3 units up to form triangle J double prime, K double prime, L double prime. So if you are moving our triangle 3 units up, what happens to our values? So if we are moving 3 units up, that means we are changing our y values and adding 3 to each of our y values. So if J prime is located at -3, 2, that means that our y value of 2 is moving up by 3. So that 2 plus 3 is equal to 5. So our J double prime is going to be located at -3, 5. We do the same for K prime. So our K prime is located at 1, 4. So we need to add 3 to our 4 because that's our y value. So now our K prime is located at 1, 7. So that's our K double prime, and then our L prime was at 1, -2. So again, our X stays the same, but our Y increases by 3. So -2 plus 3 is equal to +1, which means our L double prime will be located at 1, 1, which means our answer will be L here. So now we have solved all of our riddles. So now we need to remember what letters that we wrote down from each of our puzzles to form our Wi-Fi password. So remember that our answer to question 1 was the letter M. Our answer to question 2 was the letter A. Our answer to question 3 was the letter T. Our answer to question 4 was the letter H. Our answer to the next question was I, then S, then P, then O, then W, then E, then R, then F, then U, then L. So we can see that our Wi-Fi password is math is powerful. And remember, this PowerPoint is available to you at any time, so you can go back and work on it yourself as well. So now we have been able to call someone and escape our escape room. Great job, everybody. Last part is your homework is going to be in that same Ready workbook where we've been taking our notes. It's going to be pages 103 and 104 there. So we can see on page 103 that Ronnie dilates figure ABCD to form our new figure using a scale factor and then translate it 7 units up. So we are going to go ahead and start that question by starting with your scale factor. So doing that for the first step. Then once you are done with the first step, you're going to take that new image you formed and translate it 7 units up to find your final image. Then for question 2, we're doing the same idea, where again, you're going to start this one by translating it 3 to the left and then dilating it. So you would start with the first step of translating it. Once you find your new image, then you will then dilate that new image to find your final image. And then question 4 asks you some true or false questions based upon congruency and similarity that we have discussed. This homework assignment is going to be due tomorrow, November 11th at 9 a.m. Your exit ticket you can find by clicking on the link here. It is a 3-2-1 exit ticket that you will be working on, where it will ask you 3 things that you've learned today, 2 things you are still interested in learning, and 1 thing that you still might have a question on. I highly advise that you fill this out so that way I can best help you learn, so I understand where there might be common confusions and problems, and I can make sure I can go over them with you. This was our agenda for today. Remember that your homework is those pages 103, 104, and to make sure you get your second iReady lesson done by Friday at 11:59 p.m. If you have any other questions, please let me know. Other than that, have a great day. Bye.